All right, good afternoon, everyone, and welcome to the Embraer product webinar. Today, we're going to learn about the C390 Millennium. Before we get into it and I introduce our guest speaker, let me go through a little bit of housekeeping. It looks like everyone's doing this. We've muted our microphones and disabled video. Thank you all for doing that. We are recording this session. It's going to be in Empower later on for those of us that were not able to attend. So if you know anyone that was wanting to see this but was not able to do it, you can let them know that it'll be in Empower. There will be some time for Q&A at the end of the session. So if you wouldn't mind, if you have questions, make note of them and have them ready for us at the end. And as always, we will have a post-session survey. Not long after this session is over, you're going to get an email with a link to the survey. If you would, just take 2 to 3 minutes. Let us know what you thought about today's session and give us ideas for topics for the future. Also in there will be the link that I was just talking about for this recording. So if you'd like to see this in the future, you'll have that link right there. So with that, I'd like to introduce our guest speaker for today. Our guest speaker is Bruce Bunin, the VP of Business Development for Embraer North America. Bruce, it's great to have you here today.
Hey, thanks, Chris, and thanks, everybody. And sorry, everyone, for the couple of technical difficulties we were having there in the beginning. Yeah, what I'm going to do after discussing this with Chris is just spend a few minutes talking about EDS. The thought was that not everyone may be completely familiar with what EDS is all about in Embraer, and then focus on the C390 and talk about that. And we should have plenty of time for questions. I've got a few slides to go through. We can do, and then we'll try to run a video that kind of summarizes everything I explained about the airplane to you, and then we can discuss further. Just about me, I joined Embraer in 2016. I spent 34 years at the Boeing company in a variety of jobs. McDonnell Douglas actually before Boeing, before the merger of those two companies. And the reason I ended up, after retiring, coming back to work at Embraer is I spent a number of years in the military air mobility business in Boeing, or what we called airlift and tanker business. And this was a new market for Embraer when we started with the C390 program, and that's what led me here, and it's been terrific. So yeah, I lead business development for North America for defense. So that's my job. Let's see if I can make this thing go. Okay, so we all know that these are the 4 primary business units in Embraer, defense and security being one of those. What you may not know is that the company was actually born out of defense. It was formed in the 1960s spinning off of an airplane development program that was going on within the Brazilian Air Force and the Institute of Technology in São José dos Campos. And I won't spend too much time talking about it with you, but you can, if you're not familiar with it, it's certainly interesting where the history of the company came, which started with a strategic plan from the Brazilian government and the Brazilian Air Force. So we've been in the defense business a long time as a company, even though most people think of us as commercial jet company. These show the kind of numbers that we've achieved in the company over the years in terms of number of aircraft delivered and in service, and the number of customers we serve in each segment of the company. Defense and security, while we are certainly known for some of the airplanes that we've built over the years and delivered, there's also a set of additional companies that are either subsidiaries or partnerships, or what began as subsidiary product lines that were integrated into defense and security. And some of those are listed there, and I'll talk a little bit more about that. This services and support obviously supports all of our business units as well, including defense. And this just gives you an idea today of the current size of the military fleet and the other fleets that Johan's organization supports. So we have a pretty global presence, even in the defense sector, in terms of maintenance and support. Defense and security that's our market and EDS. And we are a global defense exporter, not only from Brazil, but actually now over the past 5 or 6 years, also from the U.S. The two primary aircraft products that we have are the A-29 Super Tucano, which we build in Brazil at GPX, and we also build it in Jacksonville, Florida, which began under a contract to the U.S. Air Force several years back to deliver A-29s to the Air Force, who then provide them to Afghanistan to stand up an air combat capability for the Afghan Air Force. Since then, we've been selling A-29s through FMS contracts to other countries, including Portugal, and currently we're producing them for Nigeria. And we've also signed a contract to deliver 3 of the airplanes to the U.S. Air Force, actually for Air Force Special Operations Command, for their combat air advisory mission. You may have read over the past several years there were some initiatives underway in the Air Force to build a light attack capability within the United States Air Force. Unfortunately, after getting really close to going forward with the procurement a couple of years ago, the Air Force pulled back on that plan. That was a very big opportunity for us, but we haven't given up on that yet. And then, of course, the C-390, which we do build also in GPX, and that'll be the subject of our conversation today. This gives you an idea of the breadth of products in defense. So besides the 2 airplanes I talked about, we do produce special mission versions of either our commercial jets or hopefully our executive jets. I personally have had a few campaigns going forward that we either were or are currently working on, looking at military derivatives of either the Phenom series or was the Legacy and now the Praetor series. And we continue to market those products with U.S. government customers and others around the world. But then along the bottom of the slide, those are all the product lines that are connected primarily to our subsidiary companies, or as I said, subsidiaries that have been folded into the core of Embraer. And it's a range of products, right? From command and control to border control, C4I systems, sensors, primarily meaning radars, air traffic management. More recently, we want to, you're probably familiar, we want a program with the Brazilian Navy, with other worldwide partners for the Tom DeMera class of ships. And then we're now recently entered into the digital security or cybersecurity world with the investments we made in a couple of cybersecurity companies, including taking a majority position with the Brazilian company Tempest. So EDS is becoming a fairly diverse company, and I think we all hope to see that continue. In terms of where we are in the world, this gives you an idea of where our products are, products and services around the world. 60 countries in just about every continent. Okay, let's talk a little bit about the C-390. I know that's probably the most interesting thing that we can talk about today. If you're not familiar with the market, the C-390 is in the airlift and tanker market, or what the U.S. Air Force calls air mobility. And that is either airlift aircraft that are designed primarily to transport cargo and or troops from either point A to point B, or to deliver them through the air via airdrop. Or tanker aircraft, air refueling aircraft that are designed to do aerial refueling of other airplanes. The C-390 can do a little bit of all of that, and I'll talk about it some. But it began with the need for the Brazilian Air Force to replace their aging C-130H models. So the Brazilian Air Force has a fleet of older C-130s, and a number of years ago, after considering whether to acquire the newer Lockheed Martin C-130J or to go forward with the development of a new product, they chose the latter. And so this program was a Brazilian Air Force development program, and the airplane was designed under contract to the Brazilian Air Force. And we are now in the production phase while we continue the development and certification work on the airplane. Part of the criteria for the airplane was its mobility capability, and I'll show you a little more about that. But basically, we carry probably 15 to 20% more in payload capability in terms of weight, at least, than what the C-130, depending on the type of cargo. And I'll talk about that a little bit more. In terms of design, the airplane needs to operate in virtually every military environment that could be envisioned. That is a normal requirement for a tactical airlifter that is intended to operate, and potentially in forward operating bases in areas where there isn't always a paved runway or a lot of infrastructure on the ground to handle the airplane. And so it's been designed for that. Also designed for maintainability, and we really talk about this a lot when we talk to customers about the airplane, because it is a discriminator. Everything we know about designing for maintenance and support, everything the company has learned over the years through the design and manufacturing of commercial jets and business jets has been folded into this airplane. And it really is a discriminator when we're out there competing against the market incumbent, if you will, the C-130 and the C-130J, because we're just new. We're a new modern airplane designed with modern design techniques and technology. And the C-130, as much as it has been upgraded in terms of avionics systems and mission systems on the airplane, it is still a very old airframe design that was designed originally way back in the 50s. So some of that just can't be changed with the C-130. We're also a truly multi-mission aircraft. And what we mean by that is that our airplane is designed to be modified from one mission set to another very quickly in the field by the operators, rather than having those airplanes dedicated to one mission set. So if you're familiar at all with the U.S. Air Force and their C-130 fleet, they have designations for the different models, right? The basic airlifter, the C-130J, but then you'll see a tanker version called the KC-130J that the Navy or Marines operate. Special Operations Forces operate the AC-130, the HC, the MC, and they all have different mission sets with specific mission systems that are designed and integrated on the platform for those missions. A lot of countries can't really afford to do that. And so what the Brazilian Air Force wanted was something that was more flexible and was easily reconfigured between those missions. And so that was a design pillar of this airplane as well. And finally, state-of-the-art technology where it makes sense. I think you'll see in a couple of later slides that in some cases the engineering team for this program made selections of more mature known quantity systems, and in other areas chose more advanced or more modern systems, and there were reasons for all of that. Summarizing the airplane's operation, as I mentioned, its structural design is what we would refer to from an engineering standpoint as damage tolerant. So it's the difference for the engineers out there, the difference between a safe life structural design philosophy and a fail-safe philosophy. And that what that allows is the airplane to, rather than have life-limited parts all over the airplane, including the structure, it's a philosophy much more like commercial and airplanes today, as well as our executive jets, where you have a maintenance program that includes inspections, and you have a tolerant design that allows for failure of a component but detection of that failure and replacement of that before it turns into something worse, right? Again, operating in all kinds of environments from Arctic and Antarctic conditions to high hot conditions, desert conditions. The airplane needs to be able to do all of that. And it's also designed to operate off runway, as I mentioned earlier. So it's designed to the worst semi-prepared runway standard from the US MIL standards. And the landing gear is designed to handle that. Just to give you a look at what the airplane looks like dimension-wise, you can see it here. I would tell you that from a planform standpoint, it's very close to a C-130 in terms of span, span and length and height. Here's a cross section of the cargo compartment. The biggest difference here between the airplane we're primarily competing against is that the ramp is at a much more shallow angle, which has is fundamental to the design. But it enables easier loading and unloading of rolling stock up and down that ramp. What it takes away in the design is because of the fact that it's a longer, more shallow ramp, it does eliminate some flat floor, some length of flat floor. But this is the concept. The step in the cargo compartment there is simply where the wing box comes through the fuselage. And then here's the cross section. We are about 8 inches taller and about 11 inches wider than a C-130 cross section. And that was by design, and it enables some cargo and troop configurations for the back of the airplane that can't be done with a C-130J, which is something that, again, we leverage a lot with customers because it's for an airplane that is almost virtually the same size. It has a lot more flexibility. Obviously, I didn't mention it, but I'm sure you noticed that the airplane is a jet. It's a twin jet. In fact, the airplane looks a lot in plan form, other than the fact that it's a twin engine airplane. If you've ever seen the US Air Force C-17, the design of this airplane looks remarkably like that airplane. Basically a scaled down version of the same design. And I spent a number of years working on that program myself. I'm pretty familiar with it. But it's a twin jet and it's a Mach 0.8 airplane. So that's a characteristic that in this category out there in the world doesn't exist in an airplane this size with this sort of payload range capability and operating at that speed. So it's obviously a discriminator for us. Max payload is 26,000 metric tons. That's a concentrated load. It's 23,000 distributed because of the CG limits on the airplane, and an operating altitude maximum of 36,000 feet. Forgive me if you find this slide hard to read. I know you would in a big room, but maybe on your computers it's not too hard to see. But this gives you an idea of the range of the airplane. This particular chart was centered around Abu Dhabi, and you can see at the max payload numbers of 23 and 26 metric tons, the range is from 1,000 nautical miles to 1,400 unrefueled range. And then you can see some of the other numbers there with the circles in the green and the blue at lower payloads and for ferry range. And then the yellow line is actually the ferry range with internal tanks. I don't have a slide on it in this presentation, but the airplane has been designed to integrate 3 palletized fuel tanks that are anchored down in the cargo compartment and can connect to the fuel system in the upper part of the fuselage. And the pilots can actually use those tanks as they would, in any other wing tank. It's transparent to them. But what it does, obviously, is significantly increase the range of the airplane, which could be useful in a search and rescue mission mode. Or obviously, if you do need to transport the airplane from A to B, or in the air refueling mode. And there now you're not measuring it in terms of range, but you're measuring in terms of fuel offload, aerial fuel offload during a refueling mission. I talked about this in the earlier slide about the flexibility of the airplane. So these are all the mission sets that the airplane is designed to do. Aerial assault, which is really a paratroop jump, which can be done either out the side paratroop doors with static line, or free fall out the side doors, or off the cargo ramp, which can be opened in flight. Aerial refueling, which is serving as a tanker airplane for both fighters and helicopters. We've tested the airplane for fighter air refueling. We've tested the stability of the hose and drogue system for the airplane at speeds representative of those of the helicopters. We have yet to test with actual helicopters. We're waiting for the Brazilian Air Force to be ready for that. But when they are, we'll run those tests. And I'm pretty confident that we're going to do well with these tests. If you follow the industry at all, this was a real problem for the Airbus guys with their A400M airlifter. They, it's a larger 4-engine turboprop airplane, and they had terrible problems with trying to stabilize the hoses in flight with the outboard engines, creating a fair amount of turbulence outboard where the pods are on the wings. And I may have it in a different picture here, but the air refueling system on the airplane, if you can see that little photo in the middle, there are wing pods mounted outboard on the wings, which are optional, and a hose drogue system that emerges from each of those pods, and that's what's used to refuel probe-equipped aircraft, whether it's fighters or helicopters or other transport airplanes, or even another C-390, which we are going to test next year. Aerial resupply, airdrop. We can do a variety of missions with that. There's all kinds of special operations forces missions that the airplane is capable of doing. Some of those capabilities are not designed into the airplane yet, but we can certainly do it. Aerial firefighting has always been envisioned as a mission for this airplane, and we are actually working on the integration of, if you're familiar with it, the MASS-2 system for one of our customers today. Aeromedical evacuation, we don't have a picture of it there, but the airplane can be configured with patient litters and emergency medical equipment systems to serve as Aeromed in the Aeromed mission. And obviously things like humanitarian aid is something we can certainly do with the airplane. And finally, also search and rescue, which is another mission set the airplane can do. I have just a couple of slides on the airplane itself in terms of the design. This is the cockpit. We have the Rockwell Collins Proline Fusion avionics system in the airplane. It is the same system that we have in the Praetor series jets, and we have integrated that with an Embraer developed software developed mission computer system, and the displays contain information both from the avionics system and the mission computer, and they're pretty seamlessly integrated into those 5 displays. There's a lot of flexibility in what the pilot can call up, and it's really transparent as to whether the information is coming from the mission computer or from the avionics system. It's also a side stick airplane. The difference here is that these are the BAE Systems active side sticks. It was the first implementation of this, not only for Embraer, but I think in a transport airplane. I think the first company to put those in an airplane was Gulfstream. For a military mission, it's really a great feature because those things are linked such that when one moves, the other moves, right? And so when the pilots are in a high demand, military mission, they can feel what each other is doing. You know, when it's basically whoever's stronger wins, right? So that's a unique feature of the airplane as well. And finally, it is a fly-by-wire, fully closed loop fly-by-wire system, which is a big feature. There's an image of what the airplane looks like on the inside. You can see on the right, there is a third crew station, which is optional. And that is there primarily for the ancillary missions like air refueling or search and rescue, or in the future, maybe a firefighting mission, where you can have a third crew member that's responsible for handling those mission systems and taking that burden off the pilots. I mentioned fly-by-wire. This is another thing that we emphasize a lot. You know, the reduced workload and the ability to fly the airplane right to the limits of its envelope. And the reason we talk about it a lot with customers, again, is because it's just something that our direct competitor, the C-130J, can't do. They cannot change the fact that their airplane is an older design with you know, a cable type flight control system that you can never have the same capability that we have with full fly-by-wire. So the company benefited a lot from the work that was done both in commercial aviation and executive jets to then take that learning and technology and implement it on the C-390. Here's an image of the cargo handling system. It's kind of the working end of the airplane. And in the middle is kind of a drawing or a cartoon, but it tries to highlight some of the features of the system. Outboard in the blue, you can see those are guide rails for electronically controlled pallet locks. So we can run 463L military pallets that are 108 by 88, either with the wide dimension going inboard outboard and using those blue locks, or with the narrow dimension going inboard outboard, which is the 88-inch green folding pallet locks. And all of those things can be controlled by the Loadmaster station that's up there in the right-hand corner. Virtually every airdrop mission, there is parachute extraction, gravity drop, you know, you name it, just by using that control station. Also, the orange symbols in the drawing are the roller trays, which you can see in the picture in the middle left. Those things basically can be lifted up, released from the floor, flipped over, and put back into place. And so you can quickly go from a flat floor configuration to a roll-on, roll-off using the rollers, unidirectional rollers in the floor. This system is as modern as anything out there in military airlift aircraft today, including C-17. So it's very easy to reconfigure. It's very quick to reconfigure, and in addition, you can see the tie-down points that are kind of look like they're suspended in midair across the sides of the fuselage, as well as on the floor. There are 10,000-pound and 25,000-pound tie-down points for cables or chains. And that's just an image of what it looks like with a finished airplane. That's with the roller trays flipped downwards, so that's a flat floor that you would use either when you've got paratroops on the airplane, like this is configured with the seats down, or when you're going to roll on and roll off, say a rolling vehicle or a tracked vehicle, like a tank or an armored vehicle. And finally, the airplane is designed for maintainability, as I talked about earlier. We tried as a company to be smart about where to use mature technology, where the benefit of taking technical risk wasn't there, and where we could use more advanced technology like the avionics system, right? And that you could say there's a risk there with that Rockwell Collins system, but it was pretty well known commercially. I mean, it's the baseline in the Boeing 787. So for the most part, other than a few systems that we had to do truly new point designs on, like for example our landing gear, for the most part we have a good handle on the mean time between failures and other maintenance characteristics of all the systems on the airplane. So we could predict how the airplane was going to behave pretty early on, and from a maintenance standpoint. And we've used all the modern tools for doing that, right? Like MSG3 and onboard maintenance and diagnostic systems, et cetera. Many military customers are not used to being given an airplane like this with a commercial, maintenance schedule with no depot level maintenance, but that's what we're doing. I mean, certainly where companies have sold derivatives of commercial jets to military customers, they know what that's all about. But for an airlifter like this has really never been done before. So the idea of just doing, A checks every 600 flight hours and C checks every 6,000 is a different thing for military customers altogether, and it's a real improvement. So it is a discriminator again for us. For the airplane, the Brazilian Air Force contract included 28 production airplanes. We've delivered 3 to them so far. We will deliver 1 more before the end of this calendar year. Last summer, we signed a contract with Portugal for 5 airplanes. They wanted some significant additional capabilities on the airplane, and so we're in the middle of the engineering on that right now and making good progress on that with the first delivery in 2023. The airplane had a dual certification approach from the beginning. So we went through an ANAC certification in parallel with the Brazilian Air Force military flight certification, which did not result, it did result in a type certificate, which is what you're seeing here, but it's a unique type certificate. It's a 0 passenger, zero payload type certificate. But it does mean that should we decide to pursue the idea of a commercial variant of the airplane, which we are talking about, it'll be facilitated tremendously by the fact that we already did this ANAC certification, because the incremental non-recurring effort to get to a commercial type certification is relatively small. These are the milestones that we've hit. The IOC was declared by the FAB in 2017. I mentioned the ANAC type certificate, which came a year later. And then the first delivery to the Brazilian Air Force was just a little over a year ago. And we're still working in flight tests and some development tests to get to the point of a full military flight certification by the Air Force, and we expect that to happen sometime next year. Okay, so that's all I have. I thought I would try to run a quick video for you if we can get it to work. Are you seeing, Chris, my desktop now?
Yep, I see the Millennium. I see the.
All right, let's try that.
There we go. It's working. great video, Bruce. Very nicely done.
Yeah, the guys, they've done a lot of really good videos. There are many of them out there, and they're they're available on Vimeo. If you guys are all familiar with Vimeo website, you can find most of them there. So if you wanted to see one that was focused on airdrop or air refueling, or our guys have done a good job at putting that stuff out there.
Great, very good. Well, let's see. We've got I think it's Q&A time, Bruce. So I know that we've got a couple questions that have come in through the conversation, so I thought I'd kick those off. And then everybody, if you have questions, if you want to type them in chat, I can read them for you, or after I read the ones that I see here immediately, I can open it up, because I think we've got about 20 people or so on the call, so it should be fine. Bruce, the first question we have is, will the aircraft ever make an appearance in Melbourne for viewing? Is that a possibility ever?
That's a good question. It has made appearances before in Jacksonville, not necessarily because we just wanted to show it to employees, but because it was a stopover point when it was moving from A to B. I don't know why we couldn't do the same thing going through Melbourne. So it's a great question. I will I'll talk to our guys about that.
Yeah. Make that happen. That'd be great.
It's entirely possible, right? I mean, because when we take the airplane, either a lot of the flight test campaigns that have been executed are still going on, or are conducted in the U.S. And when we move the airplane, let's say to an air show, if in this world we ever start having air shows again, we normally would fly through the U.S. before heading, let's say, to Farnborough or Paris. So we might be able to make that happen.
Good. Well, the second question, I think some of this was answered in the video, but I will ask it and see what you have to say about this one. But can you give some examples of what can fit into the cargo area? For example, 3 tanks, 2 helicopters, so on and so forth. I remember part of the video they showed it was a mixture there, but do you have a general answer for that?
Would help if I got myself off mute.
Oh, there we go. Yeah.
I don't have those things memorized, but I could probably, while we're talking here, I could probably pull up a slide and show you. But basically, it's a limitation of payload and or volume, right? So, for example, a military tank. Yeah, we can carry one, but it's going to be one, right? Because of the payload. We're going to be limited in terms of max payload on that. Whereas with palletized cargo, it might be a limitation of volume instead of weight, depending on what we're carrying on those pallets, right? But the basic configurations are for the 463L pallets that I talked about. We can carry 7 of those with the dimensions being the wide dimension of the pallet being inboard outboard, or we can carry 6 of them if we line them up with the long dimension going fore and aft. And this was something I alluded to when I was talking about the payload arrangements. We can, when we orient those pallets fore and aft, we can also carry paratroops along the sidewall seats that you saw in the one slide with those seats folded down. That's a payload configuration that that our competitors can't do. Let me just bring this. I can share this because I just pulled up a more detailed briefing. Bear with me here. Yeah, it figures that it's not letting me do that, but I'll try to bring up a slide here where I can show you some of those configurations. But it's basically the 7 or the 6 pallets with 36 troops. We can carry 80 paratroops I'm sorry, 80 troops in the back of the airplane or 66 paratroops, and that's simply because of the additional gear that the paratroopers have to carry. For medevac, we can carry, I think it's up to 74 litters with 8 attendants, or we can change it, and plus some cargo on the ramp itself. And by the way, I didn't mention that when we were looking at the images, but in the 2 configurations that I described with the pallets, 2 of the pallets are carried on the ramp itself. So there would be either 4 or 5 carried on the flat floor, and then 2 would be carried on the ramp, which folds up into position. And there are limitations on the weight that we can carry on the ramp, but those are actual pallet positions that we can use, for all types of missions, including airdrop.
Well, you just answered my question, because as we were watching the video, that's what I was thinking was, I wonder how much you can put on the ramp itself as it closes.
Yeah,
okay.
I believe it's 50,000 pounds is the number. That's the limitation on the ramp. Oh, no, I'm sorry. That's not right. That's not right. That's around our max payload. I
Okay.
believe it
I was
is.
gonna say, that's a good ramp.
Yeah. I believe I believe that it's 5,000, but I'd have to double check that.
Okay, great. Actually, Bruce, is it okay if I share that link to the video that you shared?
Sure.
Okay, guys. So what I'll do is in my email with the survey link, I'll also have the link to the video, so that you can see that again. And I know that some of that information is in there, so that would be helpful. I'd like to move on. So Carva has he's got a comment and a question. So first, he thanks you for the great presentation, but he wants to know, what are the main challenges that we face when competing against the C-130J?
Yeah, it's a great question. I mean, there are a number of them, right? I mean, the first and primary one is that they have an installed base, right? So the C-130, the original C-130, was sold all over the world, and Lockheed Martin has really had a virtually a monopoly on that segment of the airlift market. When I was at McDonnell Douglas before Boeing over the years, we worked hard and tried many times to come up with concepts and ideas that would lead the Air Force to do something different in tactical air mobility, but they never did. And then Lockheed, I will say, we have to give them credit. In the 90s, they took a risk. The Air Force stopped buying C-130s, but Lockheed spent their own money to develop the J model and actually launched the product with an initial sale to the RAF in the United Kingdom, and then not too long after to Australia. So they actually went ahead and made some commercial investments in the product, developed the J, sold it internationally, and then eventually the US Air Force decided to buy some as well, and they're still buying them today. So virtually these airplanes, with the exception of air forces that are willing to buy Russian or Chinese products, which are very few, these airplanes are all over the world. And so it's the idea of switching, right, from a known quantity to a new unproven product that makes our sales campaigns very challenging right now. Right now, on top of the fact that, I will say I have nothing, we have advantages over the J, but it's still a good airplane, right? It's been serving the nation and the world for a long time and doing great things. We think we have a better product, but we've got to prove ourselves in this market, and that's been a big obstacle, right? We competed a year or two ago for a campaign in New Zealand. They chose the C-130J over the C-390, and the primary reason was that we were simply unproven at that point, right? And frankly, we're still in development flight tests now, right? You saw in the video some of those images of the airplane landing on dirt strips. Those, as you probably could tell, were not real, right? Those were synthetic images because we haven't done that flight testing yet. We're going to do it in 2021. So once this airplane, we deliver more of them to the Brazilian Air Force and the airplane begins to prove itself in the field, we'll have an easier time. The other thing that makes it tough for us, as my friend Mark Schrammick I saw is on the call, is that the U.S. government is a strong salesperson for U.S. products. And so Lockheed Martin has the advantage of having the U.S. government, the Department of Defense, the State Department, the Department of Commerce, the administration, their congressional constituents, they're all there to help them create and or retain jobs associated with that program. And so we are battling against that as well. And, that was something that when we were working toward a partnership with Boeing that included a joint venture on the C-390, we hope to overcome or at least counteract, right, by entering into a partnership with a company like Boeing and perhaps ultimately having the ability to build the airplane in the U.S. We're obviously back to the drawing board on that at this point, but those are the challenges really. I think we've got a better product. I don't think we have a real challenge with the competing with them on price, which is something I can't really talk about, but I can tell you that I don't think we have a real problem there. It's just getting the airplane proven to military customers who are by nature, very risk averse.
So that's just naturally going to take some time.
Yeah.
Okay.
But the good news is we do have some campaigns around the world where we're getting very close. I'm really hopeful you're going to see an announcement of another deal before the end of the year, and when those things start happening, when we start seeing air forces, making that leap to take the risk on a new product like this, that's gonna make a big difference for us.
Very good. So next question, Ophelia from our Mesa location asks, she's got two questions, and I think you just answered the one. But the first one is, how long does it take to build a C-390? Her second half was, how much do they sell for? But I think you just said you're not able to talk about that.
Yeah, we really can't talk too much about that at this point. But as far as the lead time goes, it's about a 2-year lead time. And that is a function of our current production rate, right? So we're building at it. We're still at what some people would call initial low rate production, right? So we're just building at a rate of 2 or 3 airplanes a year at this point, and so our lead time is obviously affected by that. We can knock that down considerably if we have the fortune to sell enough airplanes to increase the rate in GPX. The factory in GPX can produce at a rate of 24 airplanes a year, and our supply chain is supposed to be able to do the same if we get to that point. I don't envision it with a product like this in a market like this that we ever get to a rate up that high, but if we could get to a stable rate of 10 or 12 airplanes a year, we could bring that lead time down probably to 18 months or less would be my guess.
Got it.
Not being a production guy, but that's my guess.
Okay. So our next question comes from Ron Behrens. Ron asks, besides the flare dispensers, what else does the C-390 carry for self-defense and crew protection in enemy skies?
Yeah, that's a good question, and I did not cover it in the presentation. So yeah, what you saw were the images of the chaff and flare system being deployed on the airplane. We also have we basically have a full suite of defensive systems on the airplane. So missile warning, radar warning, chaff and flare, and actually we have the capability to integrate additional systems if they were desired. But yeah, it's pretty much the standard military airplane you know, a self-protection system suite of products.
Got it. Very good. And Davidson has a comment. Just wanted to say, great presentation. Thanks very much, Bruce. And with that, that's all the questions we have in the chat. But if anybody has any questions that they'd like to ask directly to Bruce, we've got about 4 more minutes in the hour. So just unmute yourself and you can ask your question. I'm not getting any takers, Bruce. I'm wondering if you answered all the questions, which is good.
Well, hey, I think thank you all for attending. I hope you found at least some of this interesting. If you do have any questions that pop into your mind, feel free to just send me an email or send me a message on Teams, and I'd be happy to answer some more questions. Or if you have some interest in a particular feature on the airplane, I could just send you a couple slides that shows you some of these. Some of the things that you're interested in.
Well, actually, we do have a hand up. Christine, do you want to unmute yourself and ask your question?
Yeah, sorry, I'm not trying to end things on a negative note, but I remember maybe I don't know if it was a year ago, there was kind of like a minor accident with the KC on landing. I don't know if it was the belly. I don't actually remember the details. I just remember it kind of halted things for a bit. I was just wondering what was the outcome of that and what caused it, and if you can speak to that at all.
Yeah, Christine, I can speak to that a little bit. Yeah, it was an unfortunate event, which sometimes happens in flight tests, right? That's why it's called test, right? It's the word test. We test things because we're trying to determine if what the airplane's capable of. We had an incident at GPX. It was not on landing. It was actually on a certification test for stopping distance. And what the guys were doing was, in order to certify stopping distance and to understand the contributions that the different systems on the airplane make to the ability of the airplane to stop, they were running tests where they basically run up to takeoff speed on the runway and then deploy one of the systems, either being brake or spoilers or thrust reversers, and then see how long it takes the airplane to stop. and from that, you can empirically understand the stopping capability of each of those systems. And then you can determine, okay, now when I integrate all those systems, what should that give me? And then you can test that, and that data set becomes the data that certification agencies like ANAC or the Air Force uses to authorize airworthiness, right? And to authorize what's in the flight manual. Unfortunately, the guys were running one of those tests, and they did not fully realize that the airplane, at the speed and mass that the airplane was currently flying at, that they were getting some weight off the wheels. And as a result, they ran out of runway at GPX, which is almost hard to believe because that's the longest runway in the Southern Hemisphere. But that's what happened. And by the way, guys, this is not something that we talk about publicly outside the company. So, please, keep that to the employees here. But yeah, that's what happened. And unfortunately, we damaged one of the airplanes, and it was not repairable. So we have been the first Brazilian Air Force production airplane entered the flight test campaign, and we have been flying that full time along with the other prototype to complete the development and certification testing.
Thank you.
Great. And with that, we are at the 2 o'clock mark. So Thank you, Bruce, for your time today. This was great information shared. And everyone have a great rest of your week.
You
Thank
too,
you again,
thanks.
guys.
Thank you.
Thanks, man.